It's a great pleasure to see you all here to listen to Kevin Hauser's talk. I'm very happy that we have so many people, despite the fact that we are in the middle of the school vacation. So this will be a great moment altogether. I'm Marilyn Anderson. For those who don't know me, I'm the academic director of the Smart Living Lab and also director of the Lipid Lab that is coming here sometimes for the first time. So it's a great pleasure for me to introduce Kevin Hauser to you today. Kevin is a professor at Oregon State University that he joined about 2 years ago, and there is responsible to set up and develop a new program, a new undergraduate program in architectural engineering within the engineering school, and to try to get a flavor of architecture embedded into the engineering's minds. So before that, he was a professor at Penn State University in architectural engineering. And before that, he was a professor at Nebraska University, also in architectural engineering, which is actually his background. And in the third year, he told me yesterday, he decided to stay in architectural engineering because he discovered lighting. The light came. So fortunately for all of us, for the whole lighting community, this happened, and therefore we can benefit from Kevin's insights and very active contribution to this field of research throughout the world. He's also the editor-in-chief of Lucas. This is a very well-recognized journal that is was developed by the Illuminating Engineering Society of North America, that he's also very, very actively engaged in, was awarded several awards from them and with other awards as well. And before all his academic roles in different universities, he actually also worked for a little while at Philips Lighting, just after his studies. And on top of everything else, he's also the co-founder of Lyralux, a startup that is developing or proposing a new LED technology. So with all of that, it's a great pleasure to have you with us, Kevin, all the way from Oregon, and we look forward to your talk.
Thank you, Marilyn. Thanks so much. I'm really excited to be here. Great to see all you. We're gonna figure this out. Got it. All right. So today I wanted to talk about human-centric lighting and smart living. And I wanted to start actually with kind of a little bit of a story, imaginary story. So imagine we have a new medical facility, a hospital that's about to be constructed. And the owner of the hospital comes to us as a lighting people, and they say, well, I want lighting to support the health outcomes of the patients and the employees and the visitors that come into this hospital environment. That seems reasonable, it's plausible, right? But a hospital has occupants that are there 24 hours a day, 7 days a week, 365 days a year. Some people are day shift workers, other people are night shift. The needs of the medical staff might be different than the needs of the people that are trying to recover, which may still be different than the needs of the visitors that are coming in and trying to interact with both the medical people and the people that they're visiting. And so on the surface, the idea of, oh yeah, we want this human-centric lighting outcomes associated with everything that happens in the hospital may seem like a reasonable request, but it turns out that there's a lot of competing demands that ultimately inhibit how we can fully encapsulate that idea of human-centric lighting for all people at all times with the different roles and responsibilities that are going to happen in that medical complex. And so today, I kind of want to talk about the nuance that's involved in this term and the way that we can really think about human-centric lighting in a way that's both rational, but also cautionary. And I should say too, if you have questions while I'm talking, I mean, we can hold to the end, but I'm totally fine if you raise your hand and interrupt me in the middle. So please don't be bashful and feel free to do that. So the outline of things, I'm going to give a little bit of context of how I view human-centric lighting and kind of background in lighting in general. I'll then define human-centric lighting because it is a bit of a term that's thrown around without a lot of operational meaning to it. And I want to provide an operational definition for how I'm going to use it in the balance of the talk. I want to frame the problem. What really is human-centric lighting? What are the needs that we actually have as people in architectural and the built environment? And then what is our opportunity for lighting specifically? Like, what do we know today that we can reliably apply within the built environment that likely is going to actually have beneficial, positive human-centric outcomes. And then I'll wrap it up with some conclusions. So that's kind of the plan of attack. So for context, some of these things I'll go through rapidly because given the group that's in this audience, you've probably seen these kind of numbers, but as you probably are aware, on average, people in the developed world tend to spend about 90% of our time indoors. It's a massive amount of time. And because of that, that means buildings are acting on us in a very profound way. They're affecting how our biology works, our physiology, our psychology. So they're affecting who we are as people. And because of that, and because of the role that light plays in this, light is indeed affecting how we operate, how we sleep at night, how we act during the day. And because of that large connection between lighting and then human outcomes, we really need to think carefully about how we design and build buildings because we are affecting human outcomes. We have 4 primary variables that we deal with in lighting that are listed there. So we have time, intensity, the spatial pattern of light, and the spectrum of light. So time, we're really talking about when we turn the light on and off. So if we think of daylight, for example, ignore interior lighting for a moment. The sun rises in the morning, it sets at the end of the day, and we have this pattern that's cyclical. With electric lighting, we kind of can not necessarily use that pattern if we don't want to. We can turn the lights on and off whenever we want. So we can control that. As a lighting designer, we can design dimming systems, we can design on-off switches so that people in an interior environment have control over the time of use for their lighting system. Independent of that, we can control intensity. So whether the lighting is very bright or very dim. We can also independently control spectrum. So at the extreme end, whether we have red light or blue light. But even if we just consider white light, we could have warmish white light or coolish white light or some variations of white light. And again, we can control that independently of whether it's bright or dim and independently of whether it's on and off. And then the pattern of light finally. So we can put light so that it uniformly washes somebody's face, uniformly washes a desktop, illuminates a wall, creates scallops and bright patterns. And that is also independent of the time, the intensity, and the spectrum of the light. So these end up being 4 completely independent variables that we can manipulate in order to structure a luminous environment that we're going to experience, whether that's indoors, outdoors, on a plane of a face, on the plane of a wall, in a room overall, on an urban scale, but we can control these things at all of those different levels. These interact, that's about the extent of what I can do with animation. So often we're controlling them, even though they are independent, we control them together. So for example, in this room right now, it's modestly bright, it's modestly uniform, it's overhead. It's probably very different than what you have at home in your residence. So when you go home, you might have warmer light, probably more non-uniform. And so you might be coupling the spectrum of light, changing from a crisp white light to a warmer, maybe a yellower light, with the spatial pattern going from uniformity to something non-uniform. So even though we can control them independently, we often do control them together. So I'm going to talk a couple ways about human-centric lighting here before I get into sort of an operational definition. I kind of want to talk about what it is and what it isn't. I'm starting here actually with a quote, which you can read there. Michael Pollan, he's an author that writes a lot about food. Maybe some of you have heard of him, but I'll let you read this quote, which is about food. And then I'm going to just replace a couple of words in here. So if you're concerned about your health, you should probably avoid products that make health claims. Why? Because a health claim on a lighting product is a strong indication it's not natural light, and natural light is what you want. So I'm taking the words he put in food and introducing light here. But the truth is we see a lot of marketed products, lighting products that have in big, bold letters, human-centric lighting. And they're not always human-centric lighting. And I don't really truly mean this in a negative way. There's actually beneficial things about marketing. There are good marketing phrases. Nike says, just do it. And usually that's also good advice, you know, just do it. So lighting can, in fact, products are an important part of human-centric lighting, but human-centric lighting and human-centric labeling are actually different concepts. So to say a little bit more about this. This is some marketing trends that are suggested about human-centric lighting. 2020, human-centric lighting market was about $1 billion. 2027 is expected to go to greater than $5.5 billion. So I look at this and I think, I don't think so. What this really means is that lighting products not previously labeled as human-centric will begin to receive the label of human-centric, and this category will grow because the labeling will grow, not necessarily because the actual product category will grow. And as I will also show as we get a little bit deeper into this, we can accomplish human-centric lighting outcomes using regular lighting products. We don't need a human-centric label. We can take existing lighting products, apply them in an intelligent way based on grounded principles, and we don't necessarily need fancy labeling to do that for us. So another thing about human-centric lighting is that it may be misguided, and I've given a couple reasons here. The primary way it can be misguided is, particularly at night, artificial light at night or outdoor nighttime lighting, for two reasons. One, outdoor light or even indoor light at night, it exerts a direct negative impact on us. So when we expose ourselves to high levels of light at nighttime, it disrupts our sleep patterns and adjusts our hormonal balance. But there's also indirect negative effects on Earth's ecosystem. So light at night disrupts, for example, bird migration. I have a slide coming up next where I'll show that. And so we really need to think beyond just what's our immediate short-term need. Like, I want to light this monument at night. Okay, but I light this monument at night and then birds fly into it and birds die and I decimate the bird population. So, and then what does that have to do with the ecosystem? Now the birds and the insects and the worms, they all get out of balance, and that ultimately comes back to us. Often we don't see these things on very short timescales of weeks or years, but over spans of decades, we do actually see the negative effects that come back to us. So I need to, I have a video here. How do I play this? Maybe go like this. Okay, before I play this, a couple things that I'll point out. There's going to be a red line that you'll see come through this graph like this. It's a video. That red line represents sunrise, and then there'll be a green line going later that represents sunset. And then here you can see the density. This is number of birds that are in a migration pattern. So the yellow and white represent lots of birds, and that represents very few birds. Over here, you'll see number of birds in flight. So 22.2 million are the total number of birds in flight at this time. This is May 13th, 2021 at 19:35 or 7:35 p.m. Eastern time, obviously in the United States in this case. And they're tracking birds through really radar stations that are shown there in green. So let me play the video and you'll be able to see the bird migration during this night as time goes. So the time lapse is going to be happening here. You'll see that time change. Okay, so let me hit play. So that was sunset. This is now nighttime. The birds are moving through the night. That's sunrise, and the bird migration slows down. So one more time. You can see at the peak in that, that's the peak is over 600 million birds on that one night in migration. So I'm encouraged by things like this birdcast. I don't know if there's an equivalent in Europe, you know, if they're doing something like this. I don't know actually, but anyway, this is one way these things are being tracked. But like I hope, I envision, I would love to see a future where this information gets coupled with outdoor lighting installations, and during periods of bird migration, we just turn the lights off so the birds don't run into buildings. And to put it in context, why I'm bringing this up as an example, there are certain bird populations that have really been decimated. Like billions and billions of birds have been lost since the 1970s when they started tracking this because of disorientation and running into buildings at night. So it's a serious problem, and it is causing ecological disruption. Need some water. Okay, next thing to say about human-centric lighting. Sorry, I went ahead there. That's okay, I can leave it here. It's not really a scientific term. It's a pseudo-scientific term. And this is kind of how I would define it. Integrating both visual and non-visual effects, producing physiological and or psychological benefits on humans. So it introduces these different things: visual, non-visual, physiological, psychological. And this is not my definition. This is actually the definition of integrative lighting defined by CIE, the International Commission on Illumination. And you'll see in note 3, they say the term human-centric lighting is used with a similar meaning. I wasn't involved in the CIE definition here, and so I don't know the back history of it, but my expectation or suspicion is they probably avoided using the term human-centric lighting because there are a lot of negative associations with the term human-centric lighting. And so I think they were trying to use integrative lighting, something to mean something similar without carrying that baggage of that phrase, marketing phrase, almost human-centric lighting. But this is really what we're talking about. So and importantly, it does include vision and non-visual responses, physiological responses and psychological responses, this isn't only about physiology. It's about considering the entire balance of how lighting affects people, humans. And as I indicated on the previous slide, I also like to think not just humans in short term, our short-term needs, but long-term. So anything that's causing ecological disruption is actually not really human-centric, at least not human-centric for our kids or grandkids. So to summarize this, the scientific community likes us to use this term integrative lighting to talk about integrative thinking about lighting. So integrative thinking, light as a mediator of visual, non-visual effects. Human-centric lighting is sometimes used, although depending on your audience, you may need to define specifically what you're talking about. Are you talking about color rendering quality? Are you talking about glare? Are you talking about physiological responses? All those things are part of human-centric. And then this is really, in my opinion, a modern day refresh of that term lighting quality, because that's really what we're talking about. All right, so let me then move on to framing the problem. Let me stop here. Any questions? All right, you can say them to the end.
So clear.
All right. So light has this stimulus response or cause and effect relationship. I want to be a little bit careful with how I plot this out. I'm going to start with something that I've already presented just a couple slides ago, which is these 4 variables: time, spectrum, intensity, and the spatial pattern of light. So this is what I consider to be environmental light. The way we manipulate those 4 variables is going to control the light environment that we see. This then collectively, the way that we manipulate those things, become a light stimulus that can enter through our eyes. And so that becomes our input. And then we have this cascade of effect as it goes through our eyes and affects on our body. So we have 2 primary pathways that originate in the eye. This is the traditional one that we think about, the visual pathway. And everybody in this room, I'm sure, has heard of the rods and cones and how those exert influence on our vision. We can then subsequently subdivide the visual aspects of lighting into those 3 categories. So visual performance would be like, how easily can we see a visual task? Can we see it quickly? Can we see it accurately? Can we perform it? Can we take a thread and put it through the hole of a needle? Those types of things are visual performance-oriented tasks. Visual experience would be things like, does the space make us feel relaxed or tense? Or is it visually spacious or visually enclosed? Does it feel public or private? Does the lighting help tell us where to go, like provide circulation routes and ease our navigation? Those things are all part of our visual experience. They're psychologically oriented. And then visual comfort, perhaps a little bit uncomfortably, is often defined in terms of lack of discomfort. So it's hard to say what's comfortable. It's easy to say what we don't like. So the lack of glare, the lack of visual discomfort is often how we define visual comfort as having occurred. So then we have this non-visual pathway. And relatively recently, there's a discovery of a new retinal ganglion cell called the intrinsically photosensitive retinal ganglion cell. And this maps to a different part of our brain. And it controls other things, which I've indicated here on different time scales. So we have some acute responses, like our pupil getting larger or smaller. This can happen almost instantaneously when exposed to brighter or dimmer light. We have a circadian response, which are responses that happen on the 24-hour cycle. And then we have long-term responses, which can be chronic effects of exposure to different types of light. Now, collectively, all these things are a collective response: visual, circadian, neuroendocrine, and neurobehavioral responses. So any change that we're making up here, spatial, intensity, spectrum, or time, works its way through the system and has an effect on us down here. I'm just going to summarize on this slide. Obviously, you can't read this. I have no belief that you would be able to, but this is a good reminder for me. If you want these slides as a PDF where all these hyperlinks are active, I'm absolutely happy to provide them so that you can go through and hyperlink these things. But on this slide, this is just an example of light's influence. So pupil size, suppressing melatonin, shifting circadian rhythms, modulating body temperature and heart rate, effects on vitality if you're not in a windowless, or if you are in a windowless space. I recently was involved in a review of all these topics. We have probably 200 citations in this paper, really fantastic co-authors that I worked on that. Not to self-promote, but I think it's actually a nice overview of how the physiological responses to light and how they kind of come together and inform integrative lighting. So I have one more kind of flow chart here. And before I went from stimulus response, here I'm going from high certainty to low certainty. And interesting thing, even at the top level of the physical stimulus, that's actually a really, really hard problem. So let me walk through this. This is a spectral power distribution, which is something we can measure with a spectroradiometer. And the spectral power distribution shown here is basically an energy distribution as a function of wavelength, and the one shown there is for daylight. So you can imagine putting a spectroradiometer at the plane of a person's eye, measuring the spectral power distribution, and that will be the input. Now, I'm saying that's actually the easiest thing that we can measure with the highest certainty, but Forrest Webler just did his dissertation on this, and it actually turns out to be an extremely difficult problem. But then we get to the next step. Like, even if we know precisely the optical radiation distribution that enters an observer's eyes, then what do we do with that information in terms of the cascade of effects of how it actually affects us physiologically and psychologically? So we know something about photopigment responses. These are now agreed upon by the CIE, called alpha optic action spectra. Those are plotted there. Those are for the rods and cones and intrinsically photosensitive retinal ganglion cells. But then we have something about how those photopigments combine and send a signal that leaves the retina and starts to go on to that neurological cascade back into the brain. And then we have these different pathways, the lateral geniculate nucleus, the inner geniculate leaflets, the retinal hypothalamic tract, and so on, that control different parts of our body. The OPN, for example, controls pupil diameter. The amygdala controls mood, or at least contributes to mood. The suprachiasmatic nucleus controls things like our pineal gland, which then controls our melatonin production. And so when we change something up there, even though I say high certainty, as it goes through this whole system, we get lower and lower certainty about what the outcome is going to be. And so when we finally get to the bottom where we're at a response, I put a big question mark there, because there can be a lot of other factors that are going to affect that response. So part of my point about this is light is absolutely a very potent driver of physiology and psychology, but it can hardly ever be considered in isolation because there's other factors that are acting on our system. So two more slides to talk about that uncertainty. The first one here is we have uncertainty because of non-lighting factors. So all of these things listed, whether or not you took medications, pregnancy, sleep habits, stress, diet, climate, age, all of these things can affect the input-output relationship between light and a response. We also have uncertainty because of time delay, essentially. It's interesting the way that fades, okay? Time delay. And so the main point I want to make here is the longer the delay between the stimulus and the response, the more opportunity there is for non-lighting factors to affect our response. So I've broken them down into psychophysical and physiological, and then immediate, delayed, and long-term responses. But basically, the longer-term response, the more lighting makes a difference. You know, if we look at certain things like productivity or depression, that might not happen over the course of a day. If we have really bad lighting situation, you may be able to like really concentrate and maintain productivity anyway. But if you're in a chronic environment of poor lighting, that will have a long-term effect on productivity and potentially have a long-term effect on depression as well. And so again, you know, that time issue matters. We can just manage things on a short-term basis better than we can on a long-term basis. Okay, so now coming back to this slide, time, intensity, spectrum, pattern. These are exactly the same four factors that I talked about originally in the context of vision that we can also manipulate in terms of non-visual physiological responses. And what's interesting is when we think about physiological responses, these four factors actually prioritize kind of neatly and kind of nicely. So they're not all equally important. And so let me go through these four one more time, but in the order of importance, specifically for physiological responses to light, and within the context of the opportunity for light. So the time pattern, the temporal pattern, is actually the #1 influence. It's more important than the intensity, it's more important than the spectrum, but the time is really, really critical. And this is because this is showing cyclical patterns that are kind of integrated or nested within our body for melatonin, cortisol, 2 hormones, and then alertness. And they follow a pattern that's largely governed by the pattern of light and dark that we're exposed to on a daily basis. So here's 6 a.m. in the morning and going through the day. The white is a period of daytime, period of nighttime, and that cycle continues. So if we present somebody with bright light during this period, that actually perturbs melatonin, cortisol, alertness, core body temperature. We have this adjustment by that off-cycle dosage of lighting. So time turns out to be number one. So intensity and spectrum, intensity is actually number two, spectrum's number three, but we have this one plot, a sigmoid logistic function that's important to understanding both. So before I talk about intensity and spectrum specifically, I wanted to introduce a sigmoid logistic function. And so basically on the horizontal axis, we have biological potency, and this is on logarithmic units. And on the response scale, which could be something like an alertness scale or a melatonin suppression or circadian reset or something like that, a physiological response, it's a linear response in that dimension. So we might need to go from, say, 10 lux to 100 lux on that scale to have a linear response in whatever the response is. We also have a threshold and a saturation. So above a certain light level, adding any more light is not going to have any additional effect on us. We've saturated out. And also at threshold, if we're at a really low light level and you add a little bit more, but it's still below threshold, that's still not going to initiate a response. And so what we care about is actually this region of the curve, which fortunately, it turns out, is in a region of light levels that are typical of outdoor and indoor lighting environments, where we can actually have some control by manipulating intensity or spectrum. We can actually manipulate a response. And so that's what I'll get to on the next two slides here, starting with the intensity response. Now, if you're not familiar with melanopic EDI, it's not really critical to understanding this. Just think of this as a measure of light quantity. Very bluntly, going this way would be brighter light, and going that way would be dimmer light. And we have three different responses that are shown on the vertical axis here. In the blue circles, it's melatonin suppression. In the red, it's circadian phase resetting and subjective alertness. And then we also have three different bands of light shown. So this is kind of nighttime sleep environment. This lighter gray band is evening and domestic residential. And then this is daytime or indoor light levels. So we see, like, coming down here, that corresponds to 10 lux in terms of melanopic EDI, 100 lux in terms of melanopic EDI, 1,000 lux would be there and 10,000 there. So we see we're in a range that's kind of common within indoor light levels. And we can see that by moving to additional melanopic EDI, going from 10 to 100, for example, we can move from there to roughly there, up that curve, and we can affect things like melatonin suppression and circadian reset. And so intensity actually turns out to be really important, because even though we need log unit changes, we can actually move up the curve in a practical way. Secondly, is spectrum, or I should say thirdly, as our third one. And again, if you're not familiar with this unit, it's not so important. This unit is circadian light, CLA. It's a unit proposed by the Lighting Research Center by Mariana Figueroa and Mark Ray. And here I want to point out two things about intensity and spectrum too. So let's take two of these points that are both at 100 lux, for example. So 100 lux, those are photopic lux that you would measure with a regular lux meter. But in this case, one is for daylight, D65, one is for incandescent, which would be at like 2700 Kelvin. And we can see that the daylight is more potent than the incandescent light. However, it doesn't move us like massively up the curve. It only moves us a little way up the curve. And that bracketing between, say, 2700K and 6500K, we typically wouldn't have cooler light than that in an interior or warmer light than that in an interior. And so it is kind of sort of showing roughly practical extremes on the CLA measure. If we really want to move up the curve, we need to go from, say, 100 lux to 300 lux, or 300 lux to 1,000 lux. So I liken this to saying intensity is really kind of like a sledgehammer, and you can then use spectrum for small manipulations, but it's more like kind of a little rubber mallet in terms of the effect that will have on your photobiology. So spectrum is the number three. And then finally, the fourth influence we have would be spatial pattern. And how important or little important actually varies quite a lot. So if somebody, for example, is looking out a window all day long, then the spatial direction could be hugely important versus having their back to a window and looking at a wall all day long. That could actually become more important than intensity and spectrum because it has a huge effect itself on intensity and spectrum. So here I'm just showing that like different facial features, different orientations of the light could have a really large difference. And this is this becomes actually a really critical consideration for design, and something that we're still grappling with how to deal with, because typically with the design workflow in lighting design, we might be calculating horizontal illuminance, but we can't really do that anymore. We really need to think about vertical illuminance at a plane of observer's eyes as their eye is doing this all day long, because that's going to affect the actual dose coming in. So a lot of work that needs to be done to fully understand implications. Okay, so what then is human-centric lighting? So I'm gonna talk through this specifically for day active people. I have a daily cycle, daytime 6 a.m., midnight. Here's our daytime hours shown here. And I'm gonna overlay a couple things on here. So for day active people, that's people that work during the day, sleep at night, and follow a normal cycle like that. Now, granted, not everybody does that. We have night shift workers, we have factory workers that might work third shift. This doesn't apply to them. What I'm putting up here really only applies to day active people. So what we need is we need high biological potency during the daytime hours. That means of appropriate intensity spectrum during this particular time for that particular duration. In the hours before sleep, we can lower biological potency. And then during nighttime, we really need minimum biological potency in terms of our physiological lighting. There are certain applications like a senior living center where you might want to use like dim red lighting for navigational reasons so people don't trip and fall. So there might be visual needs that have to be considered in parallel with biological needs. But in terms of our maintaining melatonin cycles, this would be very well for day active people. So I put this statement up, seek or provide. And my point about this is I think it's really useful to think about who's responsible for doing this. So is it me, your personal responsibility to actually go out during the day and seek high biological potency light? Or is it the architect, the lighting designer, the company that owns the building that has workers in their building? Is it their responsibility to provide that? I don't think we've fully resolved that. I actually think there's also some equity issues in that, like people with more flexible schedules may be able to have more control over when they can seek or provide high biological potency light and low biological potency light. You may have some workers that are basically constrained or contained into a windowless office and aren't given the ability to seek that lighting, in which case, is it their responsibility or is it the building owner's responsibility to provide what they need to be healthy? I think this is a debate that we really haven't talked a lot about, but it needs to be considered a little bit more than it has been to date. Okay, so now let me talk about buildings where people sleep, because actually I think these are the most interesting buildings. So this would include private residences. This would also include hospitals, senior living centers, retirement care places. So in this case, we really need 3 different lighting situations, because when people wake up in the morning and then throughout the day, but particularly when they wake up, they really benefit from high biological potency lighting. And then when you go home in the evening, you benefit from low biological potency lighting. And then when you go to sleep at night, you benefit from minimum biological potency. And this, by the way, doesn't necessarily mean just turning off the lights, because there are many places where light spills in from the windows from street lighting or building facade lighting or adjacent properties. And so it's necessary to block out that light so that you sleep in a dark bedroom. So we have these 3 things, and I think there actually is opportunity for innovative lighting products, whether they're labeled as human-centric or not, that maybe could have multiple purposes, where you turn the light on and it does one thing in the morning, it does something slightly different in the evening, so that you're getting high and low biological potency at those different times of day. There are some products on the market like that, but there's actually quite few at this point. Okay, so buildings where people work, learn, tend to really only require 1 high biological potency static lighting. And this is where I can come up with examples where products are touted as being human-centric, where in my view, it tends to be more of a health washing type of thing. You know, buy this particular office lighting and it changes correlated color temperature over the course of the day, and it dims and it makes up for your post-lunch dip and all this stuff. Not really. So just bright light during the day, gonna get you what you need. Okay, I have just a couple more slides here. I wanted to talk a little bit about emerging guidance within the context of those 4 things I keep coming back to: the spatial pattern of light, the intensity and spectrum, and the timing of that. So one standard that's being used in the United States. I'm not sure if it's actually being used internationally. It's called the Well Building Standard. It's basically a point-based system where that's oriented around buildings for human health. In terms of the spatial pattern within the Well Building Standard, they have quantities that are measured at the plane of an observer's eye. So rather than horizontal illumination, it's always at the plane of an observer's eyes. In terms of intensity and spectrum, they have different pathways for compliance with different units. And it's not critical for this presentation to understand the difference between equivalent melanopic lux, melanopic equivalent daylight illuminance, and circadian stimulus. Just suffice it to say, the lighting community hasn't agreed yet on how we're going to quantify photobiological response. And so currently there's at least these 3 different methods, and there's probably others that are in the research literature. And the Well Building Standard has partly adopted all of them, saying, I don't really care which one you use any of the 3, but if you use them, here's some threshold targets for whichever you choose to use. In terms of timing, the Well Building Standard requires that quantity of light between the hours of 9 a.m. and 1 p.m. for a duration of at least 4 hours. So it doesn't have to be full time, but some 4-hour period between there. And rather incorrectly, but nevertheless, I'm just repeating what's here. The Well Building Standard just says light levels may be lowered after 8 p.m. They don't say they have to be lowered, they just say they may be lowered. But if you were actually providing this quantity of light during those hours for day active people, that would be problematic. So, but the Well Building Standard doesn't really account for that.
Can I just ask, it's a 4-hour window, so what does it mean to be at least 4 hours if it's a 4-hour window?
You're right, it is a 4-hour window, 9, 10, 11, 12, 1. Yeah, you're right. So duplicates, yeah. They also have 3 points you can get. So previously it was for 1 point. If we go to 3 points, the only thing that changes is the numbers go up. Okay, so you just need more light. By the way, more light comes with other problems. More light means more energy. More light also potentially means more visual discomfort. And so these things really do have to be balanced. We also have, in addition to the Well Building Standard, there's UL, Design Guide 24480. And this is couched in terms of CS, circadian stimulus, which is developed by the Lighting Research Center. And so they have a slightly different timing here, 9 a.m. to 4 p.m. They also give some information about what to do in the evening hours. And they also do give specific guidance in the nighttime hours, with CS going from greater than to less than to less than. In principle, there's a lot of overlap, although it's not exactly the same as well. And the third one I'll indicate here is actually from a recent article by Tim Brown and a lot of eminent people working in this area, which they've put in terms of melanopic equivalent daylight illuminance, which is the quantity that's used by the International Commission on Illumination. They also have 3 time periods, although they say throughout daytime, which, by the way, I think this is highly problematic to actually say this throughout daytime, because the energy implications of this are really serious. And there's no evidence that we actually need that much light for that long of a period of time. And I have a tremendous amount of respect for the authors on here, but I will note that all of these authors are vision scientists, some of them working on like mouse models and things like that. None of these are architectural engineers or illuminating engineers or building scientists. And I think there might be some things that get lost in translation between what the scientific community on the vision science is saying and what the practical constraints might be in architectural lighting design. So anyway, I say that with tremendous respect for this body of work. But they do have, if we sort of squint and kind of back up and just look at what's going on, there's a lot of similarities between WELL and UL and the requirements of Brown. And in time, they will probably be even more similar, but this is kind of where we sit now. So in general, we know that we need to measure at the plane of the eye. We care about light going in the eye, so that's one thing. We know that we need some quantity of light, whether it's measured in melanopic EDI, CS, EML, one way or another, we need some quantity measured at the eye. We know that it's important to get brighter light during the daytime, lower light in the evening hours, very little light at nighttime. And so that's the same principle that comes through in all three of those things that we look at. Okay, so I have to mention actual daytime, right? So daytime, nighttime. I mean, clearly the most human-centric lighting we can get is natural lighting. And I think we have to take a lot of inspiration from what daylight does for us. And I'm actually super jealous in Switzerland, the way that windows are so well incorporated into buildings. We have like a lot of big rectangles in the US with interior cores that don't get a lot of daylight. And that's actually really problematic design. So even this space where we're kind of interior, we still have access to skylights that have access to windows. So we're in an interior conference room that still has daylight in it. And that's actually pretty wonderful. Now, daylight doesn't mean just big windows. So, and this is where design comes into play too. Daylight can also, it's really slow transition, but daylight can also mean visual discomfort and glare. And so daylight does require careful engineering. It requires understanding solar position, latitude, longitude, time of day, shading devices, fenestration, fritting on glass, whatever that might be. There's a lot of control techniques that have to be dealt with in daylighting. So anyway, I say that because there sometimes is a sense that, oh, daylighting just means big windows. Big windows can cause other problems, thermal heat gain as well as visual. And so incorporating daylight is really an engineering process and a design process. So I have, I believe, three more, actually kind of four more slides that are coming up, and I will be done here. So I wanted to ask the question, like, is human-centric lighting a myth? Is it something that's magical, or is it a metaphor? So we'll start with myth. So is human-centric lighting a myth? I actually don't think it's a myth, like in the sense that we can actually accomplish it. However, if we come back to that example that I gave at the very beginning of this presentation, if that owner really truly expects, and we truly promise that yes, we can provide human-centric lighting for the nursing staff, for the surgery staff, for the patients that are trying to recover, and for all the visitors, then it really is kind of a myth, because we can't do all of that simultaneously. And so in order to take human-centric lighting out of the realm of myth and into the realm of reality, we have to be really careful about priorities. Is it vision that were most important? Is it physiological response? Is it discomfort glare control? Which occupants of that space are we prioritizing the most? Is it the nurses or is it the patients? Because they have different sleep-wake cycles and they have different visual and biological needs. And if we really lay that out and have very distinct intentions about how we're going to design the lighting, then we take it away from myth and we make it more of a reality. So is it magic? I'd say it's not really magic either, because there's no doubt that the visual and biological and physiological responses to light are real. They're absolutely true. They're influenced by other factors, but they're absolutely true. And they're things that we can control and we can have an influence over with the intelligent selection and application of appropriate lighting equipment, whether daylight or electric light. And so fundamentally, I would say it's really metaphor. So human-centric lighting has become a metaphor for lighting quality with this additional consideration of physiological responses to light that we can implement with lighting equipment that's available to us today. And so the final slide that I have here is just kind of a reference slide. I've been thinking about this idea of human-centric lighting for quite some time. This is sort of my COVID-19 project, I suppose. So these are various things I wrote about human-centric lighting over the last 2 years. All of them are open access except for this paper, Human-Centric Lighting, Myth, Magic, or Metaphor, which I wrote with Peter Boyce and Jamie Zeitzer, who's a vision scientist, and Michael Herf. And if you want a copy of that, just let me know. I'd be happy to send a copy, but all the other ones there are open access. Again, happy to make these slides available. Not sure the best way to do that. You can always email me and I'll respond by giving you a link to them. And with that, happy to take any questions you have.
Thank you very much, Kevin.
Yeah.
So indeed, the floor is open for questions. You actually
Shoot.
count them.
Great presentation.
Thank you.
Really nice. I have one thing to add and a question that comes with it as well. I feel like in these presentations of human-centric lighting, one thing that is always striking, but you mentioned it a lot, is that the one component actually about human-centric lighting is sort of missing, and that is the human.
Yeah.
So we're targeting, like you mentioned this in your responsibility, like seek or provide. Like we're targeting building occupants, and the whole idea of human-centric lighting is kind of solved in the way, as in we're responsible as lighting designers to design the space in a way that then humans, the occupants, get enough light. But this is like a fallacy in the sense that they might not like engage with the lighting that we provide in the way that we want them to do.
Sure.
So what I was wondering is in how far or what is your opinion towards incorporating the occupant in the design process, but also in the seeking sort of process?
Yeah. It's a really good question, right? So like the only thing a lighting designer can do is design the light for the space that they've been asked to design. They can't control where the occupant was an hour before they came to that space or an hour after they leave the space. And it turns out that where that person was before or after makes a huge difference on how the lighting in that particular space is going to affect them. Let me give a specific example. You know, let's say somebody right before bed, they're going to read a book, and you know they're going to have a bright light on their screen, or maybe they're just going to read it on a display device itself. So one person might have spent the day on a sunny beach, and then they go home and they read their book. And you know, that light on the book or the light from the screen is going to have no effect on them because it had so much light dosage from the beach that they were at all day. It doesn't matter. Whereas another person, maybe they spent the whole day in a dark base, a windowless space doing who knows what. Now that light dose that they now get, the same as the other person, is going to have a strong effect and will suppress the melatonin and potentially have an impact on their sleep cycle. And so, you know, it's the same lighting on the same book right before you go to bed, totally different outcome. And I think that's also what's faced by architects. They just don't know who's going to be in the, you know, where the other people were. And so because of that, I think the only thing an architect or lighting designer can do is do the best they can with the lighting for the expected time that people are going to be in that space. And, you know, there's randomness.
Do you think it would be a solution to provide feedback to the occupants of how much light they actually got?
Yeah, sure.
Do you think that would increase energy demand?
I mean, I think like Forrest's project with Spectrace is, you know, sort of a step toward that kind of idea. And there are, I mean, there's like the loose commercially available device that I talked about yesterday. I mean, it does measure light and then give you some type of feedback about whether you bend your dose. Now, whether or not it's accurate, I don't know, but I do think, yeah, some type of feedback like that. You know, I get a step count on my iPhone, right? And it tells me whether I walked enough. So having a light count to tell me if I got the appropriate light exposure, I mean, there's sensibility to that. Yeah. I just don't think we know what the threshold is, like how many photons are enough.
Oh yeah.
You know, so it's like it's a nice idea, but I think we're kind of still at the blinders on. We don't really know.
And what is enough depends on what we were exposed to before anyway. So
correct.
Enough varies too.
Yeah, that's correct.
Yes,
yeah, please.
First of all, thank you very much for the great presentation. So I have a non-expert question. Sort of two-part question. When we talk about the standards, you mentioned well, and if I assume a conventional building codes and standards probably focus more on just the lux levels, not going into these other domains. On the other hand, well is sort of promoting these other variables which are relevant for lighting, and then at the same time, kind of our community is trying to come up with the metric, like minimum but sufficient number of indicators to characterize your environment for the purpose of performance assessment of buildings. So I'm just curious to hear your thoughts on this minimum but sufficient things that we need to pay attention to, like what are the key ones and how do we actually practically characterize them in the building? under assumption that we cannot characterize everything, right?
Yeah.
It would probably be too costly. And, so, yeah, what are your thoughts?
Oh, that's a really good question. So it's hard for me to answer because I'm hesitant because there's so much contextual specificity that might be different for different buildings. So I think the first thing we would need to do is we would have to have like an archetype or a prototypical building that we're talking about. So for example, what we do in a school for elementary school children, we have sort of a general idea of when that building is going to be occupied and how it's going to be used. And I think we probably could make reasonable guidance about that. But the guidance for that school building might be different than guidance for a hospital or a restaurant or retail or even a commercial office building. And so I think the first thing I would probably think about is how to, I don't know, taxonomy of building types. And then within that taxonomy of building types, like what are recommendations within them? So, I mean, for example, if we have a retail environment, color rendering is probably going to be more important than the photobiological potential, because people walk in a retail store, they have to have color accuracy to make their selections, but they don't, your photobiology is not really, you're in there a short period of time, so that's not really the driving concern. Whereas an elementary classroom, you are going to have children in there for a full day for a given amount of time. And then in that case, I think the light dosing and the light exposure actually becomes a really important consideration because you have them there for 5 days a week for X number of hours. Now, so in terms of like what the measures are, let's just take the kids' classroom, for example. Access to daylight, I would think would be absolutely critical. And that is going to essentially be coupled with light exposure, because by having appropriate access to daylight, you're also going to be increasing the light exposure. And bright light from daylight is much more visually comfortable than bright light from electric light. It's just, we're way more tolerant of it. And so for many applications, I think the intelligent, like when we care about photobiology, the intelligent incorporation of daylight is probably the most critical thing. I don't know if I fully answered that, but it's kind of a start.
Yeah, of course.
Thank you for your presentation. I really liked the part when you differentiated human-centric lighting from integrated lighting.
Yeah.
And then also along with bird migration. And I was kept thinking about, like, we talked a lot about inside a building and like human response more in terms of building occupants. But when we apply the same logic to more of a city scale with outdoor lighting and think about biodiversity, not just birds, but insect population, as well as outdoor lighting that has to consider vandalism as an aspect.
Right.
How would you, I just want to hear your perspective on how then human-centric lighting principles differs when it gets applied to a macro scale.
Yeah, sure. Yeah, it's a great question, because I mean, I think thinking on an urban scale and city scale and outdoor is really, really important. So there's a couple of things I think I wish we did. I wish we closed off our buildings when we're using light at night. So we have less of the light from the inside of the building penetrating the outside of the building. And so that would actually make our urban landscapes dimmer. And it would be better for nocturnal creatures if we were to do that. Now, the value of that probably varies from place to place. Maybe in a dense urban area, it's probably less important than it might be in, say, suburban United States community, where you have big yards and you actually do have a lot of outdoor insects and frogs and birds and lizards and all that stuff running around. I think curfews are really, really important, so that we're not operating lighting during the entirety of the overnight cycle. But there tends to be a period soon after dark where there's a lot of people walking around, but that gets thinner and thinner and thinner as people eventually go to bed. And so with LEDs, they're really easy to dim, way easier than metal halide or high pressure sodium. And so incorporating curfew-based dimming, maybe even with exterior occupancy sensing, so when people aren't around, things automatically dim. There's a great opportunity for that I think is underutilized. And so, I mean, it is used in some cases, but it's really underutilized and could be better utilized. And then I think, you know, like with the bird migration stuff, like that's one example of how maybe we could couple measurements to improve outdoor lighting situations at time of year. Another example I'll give you, the St. Louis Arch, if you're familiar with that, it's kind of big arch in St. Louis in the US. When they did the lighting installation for the illumination of the arch, they also installed basically a device that measures the atmospheric particulates. So on nights where there's a lot of aerosols in the air, like a cloudy day or something like that, they won't turn the lights on at all. They'll just leave them off. Because in those situations, you get a lot of scatter and a lot of night glow. But on days where it's really clear sky, that's when they'll light up the arch, because you're getting less of that atmospheric scatter and less urban sky glow as a result of that. And therefore less disorientation of birds, because they're not seeing it as clearly. And so like, I think we just have more opportunity to do more things like that. I don't see outdoor light at night completely going away, but I do see lots of opportunities for us to do it more intelligently so that we still get sort of the positive benefits without coming with as much collateral damage.
Maybe if I can ask one more also. So basically one of the lessons learned today is that there is a lot we don't know, and that to design a lighting environment inside is still a challenge because the needs are fluctuating, dynamic, and a lot of research is still needed. However, even if we did do somehow a good job in the lighting design, there is still the behavioral aspect. So how the building is used will make a huge difference in how much this will affect us ultimately. So a few years ago, I had a provocative comment from someone saying, well, there are two options. Either we design horribly poor buildings and lighting so that people are so depressed inside that they go outside and this is actually good for them. And so that's one option. The other is to try to induce a behavior that is good for you, assuming a reasonable lighting design. And I was wondering if you knew of any research. It looks like this is an underexplored area of research to really work on what is it about lighting that can provoke, drive a behavior that will be good for you. But for that, we have to understand what is it that drives behavior. So I'm not talking about churches or museums where, yeah, if it's dark and it's bright there, you will go there. Okay, but I'm talking about daily environment. Do you know of any research that would help start to pave the way there, which seems to be a parallel path that nobody's really taking? It's an interdisciplinary path because it requires design, very strong design and engineering, but it's
I don't. I'm thinking of it in terms of like, you know, we all know we should eat our vegetables, but we don't always eat our vegetables because that chocolate cake looks pretty good. You know, similarly, we all know that we shouldn't use screen time right before we go to bed, but it's just one more email that I'm going to get out before I go to bed. So yeah, I mean, I'd have to think about that. I don't know of any research groups that are working on that problem that you just expressed. Yeah.
Well, let's look for it. Any other questions? But then thank you very much again.